Hello students, welcome to my YouTube channel RD Academy. So in this video, we will be talking about section 1.7 of your first chapter, electric charges and fields. Okay, as I said previously, there might be a mismatch in the section number because of the reason that I am using older version of NCERT textbook. So just look at the topic and study accordingly. Okay, so now coming to forces between multiple charges. Okay, so if you remember in the previous video we have dealt with two charge system, that is I had one positive charge and one negative charge. Using Coulomb's law I defined the force acting on Q1 and Q2. So what will be the force acting on this charge? Now this charge will move in this direction because both of them are like charges and they will repel. Now this force is termed as F12 vector. And how will you read it? Force acting on charge Q1 due to the presence of charge Q2. Similarly here, for the second charge Q2, this charge will now move in this direction. Okay, so this force is termed as F21 vector. And how will you read it? Force acting on charge Q2 due to the charge Q1. Okay, now this position vector I will take it as R12 cap. Then F21 is in the same direction as R12 cap. F12 will be in the direction of minus R12 cap. So this is what we have learned in the previous video. Okay, now we will just extend this system to multiple charge system, that is system which contains more than one charges. Then we will see what happens. Okay, so to understand these forces between multiple charges, there is one theorem that is known as principle of superposition. Okay, so what this principle of superposition tells you is that, now assume there is more than two charges in the system. This is Q1. Now this Q1 is surrounded by Q2, Q3 and Q4. So now what happens? What will be the total force acting on this charge Q1? To deal with the system like this, that is multiple charge system, we use this principle of superposition. So I will just read the statement once, listen carefully. So principle of superposition states that the force on any charge, for example Q1, due to number of other charges Q2, Q3 and Q4, is nothing but the vector sum of all the forces acting on this charge due to the presence of other charges. And while calculating this vector sum, you should take one charge at a time, meaning while dealing with the Q1 and Q2 system, you just assume that Q3 and Q4 are absent. Okay, so once you deal with the Q1 Q2 system, ignore Q2 and Q4, deal with only Q1 Q3 system. So like this you have to take only one charge at a time. Okay, and the last point is that the individual forces, that is the force between Q1 and Q2, this F12 vector, it is unaffected by the presence of these charges. Okay, F12 does not change its magnitude or direction due to the presence of Q3 and Q4. So if I want to write it mathematically, I can write it as the net force acting on charge Q1. Force is a vector. Okay, so the net force acting on charge Q1 is nothing but force acting on charge 1 due to charge 2. That is the first force, right? There will be some electrostatic force repulsion between charges Q1 and Q2. You have to take that force plus vector sum. Next, ignore this Q2 and Q4. Take into consideration only Q1 and Q3. Now you will have force acting on charge Q1 due to Q3. This is another one force. Similarly, ignore Q2 and Q3 now. Deal with only Q1 and Q4. Now you will have force acting on charge Q1 due to the presence of charge Q4. This is the last term. So now here I have taken only 4 charge system. What might happen if you extend this to n charge system? Let us assume like Q1, Q2, Q3, Q4 up to you have n charges. What will happen? Similarly, you have to take the sum of all the forces, and the last force will be force acting on charge Q1 due to the presence of charge Qn. Okay, so this is what the principle of superposition tells you, that The net force or total force acting on any charge is the vector sum of all the individual forces acting on the charge taken one at a time. Okay, that is important. Now, can you simplify this further? Now, what can I write it this F12 as? That is force acting on charge Q1 due to Q2. I can write it as K from Coulomb's law, Q1 Q2 divided by R12 square into R12 cap. This entire term deals with only magnitude. This R12 cap will give you the direction. Okay. Similarly, F13 I can write it as K Q1 Q3 by R13 square into R13 cap. Okay. Similarly, F14 everything remains the same, but in place of R13 and R13 cap you will get R14 and R14 cap. Now for the last one I can write it as K Q1 Qn divided by R1n square into R1n cap, right? Now this is the principle of superposition. Okay. Now which are all the terms that are common here? K is common and also Q1 is common in every term. Take that outside. So what is the remaining term? Here you have Q2 by R12 square into R12 cap plus Q3 by R13 square into R13 cap plus Qn by R1n square into R1n cap. Okay. Now the term in this bracket I can write using the summation term. So the summation symbol indicates the terms are repeatedly added. So summation I starting from which term? 2, and it goes on till n. So it starts from 2 till n. Now this subscript you change to this general term I. So Qi divided by R1 I square into R1 I cap. Okay, so this is just a mathematical simplification, mathematical reduction of this expression here. Fine. So this is what your principle of superposition tells you. Fine. I hope this is clear and you have no doubt in this subject. So this is important, especially for solving numericals. 1 5-mark numericals will be based on this concept of principle of superposition. Okay, and while applying principle of superposition, all you need to remember is that you need to take two charge system at once, ignore the other charges. For example, here the moment I am dealing with F12, I will assume that Q3 and Q4 are absent. First I will write the expression for F12 using Coulomb's law, then ignore this charge Q2, deal with Q1 Q3 system. Okay, this Q1, it might be any charges. They will ask you like calculate the net resultant force acting on charge Q1 Q2, like that might vary. Okay, but the overall principle remains the same. So I hope this section is clear. We will see in the next video. Thank you.